Today we're going to talk about the hair, glands, nails, and we may get to some of the functions of the integumentary system. So the accessory skin structures are the hair, glands, and nails. Hair is found everywhere on human except for palms, the soles of the feet, your lips, and the distal segments of the fingers and toes. So the very ends of your fingers and toes. Now the middle segment of your fingers and toes, right in the middle, some people, if you check your own fingers, some people will have hair there and some people will not. That's kind of a genetic trait, whether or not you do. On your proximal segment, everyone has hair there. The second, middle one, some people do, some people don't. And then the distal end, no one does. The shaft of the hair protrudes above the skin surface, and the root is located below the surface, and the base of the root is called the hair bulb. So right here, here's the hair bulb. Here's the shaft of the hair, it extends above the skin surface, and then you have the hair follicle is actually this whole part of the hair. It has three concentric layers. So if you take a cross section of hair, you'd see the medulla, which is the very middle. It's the central axis. It's a very soft center in the middle. The cortex forms the bulk of the hair. It's sometimes called the bark. And then there's a cuticle, which forms on the hair surface, is overlapping and holds hair in the follicle. And if you take a piece of hair out of your scalp or wherever, and you run your finger along it in one direction, it will feel very smooth. In the opposite direction, you're going to feel it's kind of rough. It sticks to your fingers, and that's because you're going opposite the cortex. I guess the cortex, you could think of it like styrofoam cups. They're all overlapping one another in one direction. So it'd be like you're going up when you go up the styrofoam cups, your fingers are kind of catching on it, and that's what makes it feel a little rough. If you go down the hair, then it's going to feel smooth. So the hair follicle extends into the epidermis and into the dermis. And when hairs are pulled out, the internal part comes out and is visible as a white bulb. So sometimes, like girls, when you pluck your eyebrows, if you look at the hair, if it has a bulb-looking area on the end, you've pulled the hair bulb out and it won't grow back. You've actually pulled the follicle out. The hair bulb has an internal matrix. It's the source of the hair. The dermis projects into the bulb and it gives it its blood supply. This picture in the bottom right gives you that cross section of the hair where you have the medulla, the cortex, and the cuticle on the outside. Here you can see the blood supply going to the hair follicle right there. So the hair growth, it grows in cycles. It has a growth and resting stage. In the growth stage, the cells are added at the base and the hair elongates. The average rate is about 0.3 millimeters per day on average, and eyelashes grow for 30 days, and scalp hair for 3 years, and then they would fall out. The rest stage is the follicle shortens and holds hair in place. It rests, and then the hair falls out of the follicle, and then a new hair begins. So a rest period for eyelashes is about 105 days, scalp hair for about 1 to 2 years. Regular hair loss means that hair is being replaced. So when you shower in the bottom of your shower, the drain, you're going to always find hair there. That's normal. You're going to have regular hair loss, and that hair that's falling out is being replaced. Permanent hair loss or pattern baldness can occur, and that would be unusual or irregular hair loss where you're going to lose hair and it's not going to grow back. Hair color is caused by varying amounts and types of melanin. Melanin can be black, brown, and red, and we talked about melanin and its function in skin yesterday. And then there's muscles attached to the hair follicle. They're called erector pili, and they're a type of smooth muscle, and when those muscles contract, it causes hair to stand on end, and it gives you goosebumps. And how that, if you think about animals like dogs or cats that are covered in fur, if they were to get goosebumps, it, for one, can help make them look bigger, so it can help them in protection, and then also, if they're cold, it helps insulate them when they do that. So that's the use of the erector pili muscle in animals. Glands. There are several different types of glands we'll talk about. Sebaceous glands, they have an oily secretion that's called sebum. Sometimes we call them oil glands. Prevents drying and may inhibit bacteria. And most empty into a hair follicle. So right here is a sebaceous gland. It empties in the hair follicle, and then it comes up through the actual follicle and opens up and where the hair shaft exits, the epidermis. There's some exceptions like the lips and on the eyelids, because you don't have any hair on their lips and eyelids, so there are sebaceous glands below the surface there. Sweat glands, there's two types that are traditionally called apocrine and merocrine. Merocrine are the most common, and they are simple coiled tubular glands, and they open directly into the surface of the skin, and they have their own pores. They're coiled and part of the dermis, and then they go through the epidermis and exit to the surface of the skin. They produce mostly water with some salts, and that mixture we call sweat. And there's a lot of sweat glands the merocrine glands in your palms and soles of your feet. Apocrine sweat glands become active at puberty, and they are compound coiled tubular glands. They usually open into the hair follicles superficial to the opening of the sebaceous gland. So if you look at a hair follicle, this apocrine gland would be above the sebaceous gland. And it secretes an organic compounds that are odorless, but when they're acted upon by bacteria, become odoriferous. So that's what makes the sweat stink. And a lot of them are found in the axillae, which are your armpits. So most of those apocrine glands are in your armpits, and that's why people use deodorant to help the secretion of those the sweat in your apocrine glands. Nails. We'll go through the parts of the nail. We have the nail body, which is just an extension of the stratum corneum. Remember, that is the keratinized upper layer of the epidermis of your skin. The eponychium or cuticle is the corneum extending on top of the nail. So right here, we'll look at this. Here's the cuticle right at the end. Hyponychium is the corneum that's beneath the free edge. So if we look at this picture, the bottom picture, right here, it's attaching to the bottom of the nail. That's the hyponychium. The matrix and nail bed are cells that gives rise to the nail itself. The nail bed is right underneath the nail, and the matrix is right back at the end. Would be the proximal end of the nail bed. The nail root extends back into the finger and toe. It's right here around the same area as the nail matrix. And then lanula is the white crescent-shaped area by the eponychium right here. The growth is continuous, unlike hair, and so fingernails grow about 0.5 to 1.2 millimeters per day, and it's quite a bit faster than toenails. So there's no growth and resting stage for nails. We will go through the functions of the integumentary system. So one function is protection. So it protects you against abrasion, sloughing off as bacteria desquamination occurs. So bacteria will just be sloughed off just as your skin cells are sloughed off. Protects against microorganisms and other foreign substances. Secretions form an environment unsuitable for some microorganisms. So some of those secretions that are on your skin can help prevent foreign organisms from setting up shop there. Melanin is protects against UV radiation. The hair on the head is an insulator and protects against light and from abrasion. Your eyebrows keep sweat out of your eyes. The eyelashes protect eyes from foreign objects. It's a reflex that something's coming towards you for your eyes to squint. So your eyelashes can help protect your eyes. The hair in the nose and ears help prevent against dust and bugs. And the nails, your fingernails help protect against the, for self-defense, help protect the digits, the ends of your fingers. And it's also, the skin is also a barrier to water loss. Sensations, you can feel pressure, temperature, pain, heat, cold, touch, and movement of hairs on your skin, so there's a lot of sensations you can have. Temperature regulation, sweating, and radiation are two ways that you can cool your body down. Sweat causes evaporative cooling, so it takes energy from your body and to evaporate it, to change it into a gaseous stage, and that's what makes, when you sweat, it makes it feel cooler. And then also arterioles in the dermis change diameter as temperature changes, so you can have more or less blood flow through the dermis. If you're really hot and you're trying to release energy, the vessels will dilate, allowing more heat to radiate from your skin. If it's cold, it's going to constrict and keep more heat in. Vitamin D production, it begins in the skin, and you need vitamin D in order to help absorb calcium. So if you are low in calcium, and calcium is important for bone growth, if you're low in calcium, a lot of times you'll have to take a calcium supplement, and that calcium supplement will have a vitamin D mixed with it, or you have to take a separate vitamin D supplement also. Whole milk, the red type of milk that you can get, a lot of times will have a vitamin D supplement in it already, just so that you can help, because a lot of younger kids drink the vitamin D milk, the whole milk, and it helps them absorb the calcium better in the milk. So vitamin D, also called calcitriol, is produced with this system here. So it stimulates the uptake of calcium and phosphorus from the intestines. The vitamin D stimulates the uptake of calcium and phosphate from the intestines. It promotes calcium and phosphate release from the bones, and reduces calcium loss from kidneys, and increases the blood and phosphate levels. The function of the calcium is the bone formation, growth, and repair, also involved in clotting and some muscle and nerve function. So the precursors of vitamin D are produced in the skin that are exposed to the UV light. Those precursors are carried to the liver and then modified, and then it is carried to the kidneys, and so it can form vitamin D. People in cold climates and those who cover their body can be deficient in vitamin D, but calcitriol can also be absorbed through intestinal walls, through dairy, liver, egg yolks, and other supplements. Even in the dead of winter here, most people are able to get enough vitamin D from the sun, just from the limited time you're outside. Excretion, it's removal of waste products from the body. So sweat is a mixture of water and salt mainly, but it also has urea, ammonia, and uric acid. But really, when compared to with the kidneys, waste production and excretion is very, very minor, because the kidneys will do most of the waste excretion. And the skin can also be used as a diagnostic aid. You can easily observe and reflect on other parts of the body. So yesterday we talked about cyanosis, which was a bluish color caused by a decrease in blood oxygen content. So by looking at someone's skin, you can tell whether or not they have good blood oxygen, if it's really low or not. Jaundice is a yellow skin color caused by the buildup of bile pigments. And if you have a buildup of bile pigments, it indicates damage to the liver, because your liver isn't able to break down that bile, and so it builds up in your skin, and you can see that yellow. Now, a lot of times, babies can be born with jaundice, and it's really simple. They a lot of times they just put them under a heat lamp or a UV lamp or some sort, and it'll help break down those bile pigments. So as long as you catch it, it's easy to diagnose and treat. So there's no real lasting problems usually, unless you are having liver failure, then that's a little different. So I think, yep, that's all we're going to do today. So next time we take notes, we'll talk about burns and cancer,